Hey guys, it's Miss Adams again. We're finishing up the Unit 6B test review. Let's look at problem 23. We're looking at our boy Nick. Nick throws a candy bar from the stands to the field. Why he would do that, Lord only knows. So the equation is modeled by y equals negative 16 x minus 1 squared plus 24, where x represents time in seconds and y represents the height in feet. So it asks us, what is the maximum height the candy will reach, and at what time will that be? So we're trying to find the vertex here. Okay, so maximum height the candy will reach, and at what time that will be. So we're already in vertex form. If I write my vertex out, it's negative hk, so that's going to be 1, 24. So that means that after 1 second, my candy bar is going to be at 24 feet. And that's my maximum height. All right, so that's pretty easy. Now, how high is Nick above the ground when he throws the candy? So we got to find our y-intercept. Well, in order to find the y-intercept, we're going to have to change this equation from standard form to vertex form. Looking at that, I can use BDA, that's box, distribute, and add. So I'm going to say I've got y equals negative 16. I'm just going to rewrite the equation here. X minus 1 squared plus 24. First thing to do is to box our squared term. So I've got x minus 1 multiplied by x minus 1. X times x is x squared. X times negative 1 is negative 1x. X times negative 1 again is negative 1x. And negative 1 times negative 1 is positive 1. Then we combine like terms in the middle. Negative 1x plus negative 1x is going to give us negative 2x. This all replaces my parenthetical up here, so this x minus 1 squared is going to be replaced now with this new function, or this new form here. So I can rewrite my equation as y equals negative 16 multiplied by x squared minus 2x plus 1, and then we still have plus 24 on the outside. Second step is to distribute. So we're going to distribute the negative 16 throughout our parentheses. So I'm going to have y equals negative 16 x squared. Then negative 16 times negative 2x is going to give us a positive 32x. And negative 16 times 1 is going to give us a negative 16. And we're still going to have positive 24 on the outside. Last step is to add or combine like terms. So negative 16 plus 24. So that's going to give us that y equals negative 16 x squared plus 32 x plus 8. So that's our standard form. And we're going to want to know how high is Nick above the ground when he throws the candy. That's our y-intercept, which is here. That's your c value. So he is 8 feet off the ground when he throws the candy. So he's at 0 seconds. So he's at 8 feet. All right, let's go on to problem 24. It says solve each quadratic equation by the method of your choice, then identify key features and graph. So we can solve it by using the square root method or the quadratic formula, or you can even go back to factoring. But let's stick with these two. I prefer the square root method. It's a little bit faster than using the quadratic formula, in my opinion. So from this form, it's starting off in standard form. And from standard form, we can say that our y-intercept is at 0.48. So it says we want to solve these. Let's go ahead and solve this by square root method, and then from there we can turn it into, we can find the vertex from there, or we can actually find the vertex by changing this over to vertex form. Either way. So I'm going to say that 0 equals negative 3x squared plus 48. I'm going to subtract 48 from both sides. So now I have negative 48 is equal to negative 3x squared. And I want to isolate my squared term, so my squared variable here. I'm going to divide both sides by negative 3. Negative 48 divided by negative 3 gives us a positive 16. So I have 16 equals x squared. Then I can use the square root method, so I can take the square root of both sides. The square root of 16 is plus or minus 4. So those are my solutions. X equals plus or minus 4. So x equals a positive 4 or negative 4. Meaning that our x-intercepts are at 4, 0 and negative 4, 0. So like I said, we can complete the square to solve this quadratic equation. Or another method that we can use is using that, this goes back to Unit 6A. We were given that the axis of symmetry is x equals negative b divided by 2a. Well, in this case, we don't have a b value, so that means we've got x equals 0 divided by 2 times negative 3, which is negative 6. So the x value of our vertex is 0. If the x value of your vertex is 0, that means the vertex and the y-intercept are the same value. So our vertex is also 0, 48. Our axis of symmetry here is x equals 0. So let's go ahead and graph this equation. We have our vertex and our y-intercept at 48. Let me make this a little bit thicker. So I'm going to have 1 point at 48. And then my x-intercepts were at positive 4 and negative 4. So if I graph this function, it's going to look something along the lines of there, where our axis of symmetry is now where x equals 0. So that's our y-axis. And then we have an x-intercept at positive 4, x-intercept at negative 4, and a vertex and a y-intercept at 0, 48. Okay, let's go over to our last question in this test review. So y equals 2 multiplied by x minus 3 squared minus 8. That is in vertex form. So let's write that out as vertex form here. So we already know that the vertex is going to be negative hk. So 3, negative 8. And let's solve this one by square root method as well. I feel that the square root method is probably your quickest method to solve these equations. So I've got 0 equals 2 multiplied by x minus 3 squared minus 8. First step I'm going to do is add 8 to both sides. So this gives me 8 equals 2 times x minus 3 squared. I'm then going to divide both sides by 2. 8 divided by 2 is 4. So I have 4 equals x minus 3 squared. So now I'm going to take the square root of both sides. Square root of 4 and the square root of x minus 3 squared. Square root of 4 is going to give us plus or minus 2. And that's going to equal x minus 3. So that means my solutions are going to be x minus 3 equals 2 and x minus 3 equals negative 2. And if I do the math there by adding 2 to both sides, 2 plus 3 gives me a solution of x equals 5. And then negative 2 plus 3 is going to give me that x equals 1. All right, so now how can we find the y-intercept? We could do BDA and solve to where we get the whole equation in standard form, or we could just set x equal to 0. because we know when x equals 0, that's our y-intercept. So let's just do that. I'm going to say that y equals, I'm going to draw it out over here, y equals 2 times 0 minus 3 squared minus 8. That's going to simplify to 2 times negative 3 squared minus 8. That's y equals 2 times 9 minus 8. 2 times 9 is 18. That's y equals 18 minus 8. So that simplifies to y equals 10. So your y-intercept is going to be at 0, 10. And if I'm writing out my x-intercepts, they're just going to be one at 5, 0, one at 1, 0. And your axis of symmetry is just your x value of your vertex, so that's when x equals 3. Okay, let's graph these points. So my vertex is at 3, negative 8. So I'm going to go to the right 3, down 8. So it's right about there. There's my vertex. My y-intercept is at 0, 10. So I'm going to go up 10, but I don't really have room for my y-intercept. It's pretty far off the graph. So I'm going to assume that it's somewhere up around here. No worries that it's not lying on the graph. It's not going to affect us too bad here. And then I have x-intercepts at 5 and 1. So I'm going to put my x-intercepts at 5, 0 and 1, 0. So let's graph that out. Let's connect the dots. Looks like a parabola to me. And we would continue going up and down there. And that is our graphed form of the function y equals 2 multiplied by x minus 3 squared minus 8.